Algebra lesson 2-6, the distributed property. Probably one of the most used properties throughout this entire course in algebra is going to be the distributed property. The number that is outside the parentheses or brackets or the grouping symbol is multiplied by each number or variable or a combination of number and variables inside the parentheses or grouping symbols. This is very important. A lot of people forget that it's multiplication and they accidentally add. One of the other second mistakes is people forget to do it to all the parts inside. They'll do it to the first part of what's inside the parentheses and not the entire thing. So as an example of this, here we have in parentheses an unknown amount A and an unknown amount to B, but they're inside parentheses. Because we don't see an operation sign right here next between the 4 and the parentheses, we must assume that it's multiplication. According to the distributed property, we are distributing this number. We distribute it to the A with multiplication, which gives us 4A, and we distribute it to the B, which gives us 4B. We keep the exact same sign that is here, right there. It does not change. Now, if it had been subtraction, we could change it into addition of the opposite and go from there. But whatever, if it's addition, we can leave it as addition. These are not like parts, so we cannot combine them any further than this. It's as far as we can go. So again, it's not 4 plus A and 4 plus B. It is 4 times A, 4 times B. Another look at this with subtraction here. We can keep the exact same sign. But you'll notice that now it's 3 times the R, which is 3R, and 3 times 2V. Because you can't multiply 3 times V, but you can multiply 3 times the 2, and that creates the 6. So we end up with 3R minus 6V. Now, sometimes the distributed property, you can go the other direction. This takes a little bit more practice, and at first some people aren't very good at this. But if you notice, on 4A plus 4B, let's say that was 6R plus 6D. If you looked at both of these and you asked yourself, what's common to them? Well, the 6 is common to them, not the R. The R is only on this term, not the D. The D is only on this term. But the 6 is in both of the terms. So if you use your giant distributive vacuum and you suck the 6 back out of both of these, you could go the other direction with your distributive property and have 6 on the outside. And on the inside, you'd be left with R and D. Now, what I do when I'm looking at a problem like this, the first question I ask myself is there anything that goes into both 6R and 6D? The question answers is 6. 6 goes into both. So 6 is what I put on the outside. So I would have this sitting just like this. And I would have blanks in here. Then I would ask myself another question. I'd go, okay, if I know 6 is on the outside, what does 6 have to multiply by right here to make 6R? Well, the answer is R. Then I would ask myself, all right, now what does 6 have to multiply by here to make 6D? And the answer, 6D. That's how I would come up with the 6 times R plus D. So let's make it a little bit more complicated, not much. To give you the idea, we'll keep kind of the similar idea, 6R plus 12D. Now, 6 can still go into this, and 6 can still go into this, but it won't be the exact same answer. But I know that the biggest amount of values I can have that can go into both 6 and 12 are 6. So I'll put 6 out like this. I know it's addition here, so it's going to be addition there. Now, again, I turn right around and I ask myself, okay, what would this 6 have to multiply by right here to create 6R? The answer, R. But what would this 6 have to multiply by here to make 12D? The answer is not D anymore, the answer is 2D. So that's a little bit different. You can always check to see if you've done this correctly by actually doing the distributive property again. 6 times R, 6R. 6 times 2D, 12D. Yes, I did it right. So again, checking is always a good idea to see if you've done things correctly. Alright, next, we have what we call a coefficient. And the coefficient in a term, so remember from our definition before that a term is the product of a number and a variable, all right? I mean, a term is a chunk being added, but in this case, we want the term to be the product of a number and a variable. The number is the coefficient. We don't write numbers R3. We're going to write them, that's not how we want it. We want it to be 3R. So this is not the form we want. We want 3R. And if you're looking at coefficient in a term that's a product, remember product means multiplication, then the number in front of the variable, that would be considered our coefficient. So our coefficient in this problem is right here. That's the coefficient. The coefficient would be 3. If you had 7t squared, the coefficient would be 7. That's the coefficient. The number in front of the variable. This is all important because when we start talking about terms with the same variable or variables raised to the same power, that means they must have the same exponent, then we consider those like terms. I also refer to them sometimes as like parts. Like terms, like parts. You got to make sure you're dealing with the like terms or like parts because you wouldn't want to put Chevy parts in a Porsche engine. Not the same kind of parts, it's not going to work. So if we look here, here's some examples. 4x and 10x. These would be considered like parts. They don't have the same numbers, that's okay. But they have the same variable, x, and both the variables really have the exponent of 1, which means they are raised to the exact same power. They're both powers of 1. So those would be like parts. Now we have 3b squared and 7b squared. Again, 3 and 7 are not the same, but that doesn't matter. Those are the coefficients. The coefficients don't have to be the same. What does have to be the same is b and b squared and squared. If this one wasn't squared but this one was, they would not be like parts. 6df, 8df. The coefficient doesn't have to be the same, but the variables do, and both of them are to the same exponent. Here's an example of one that is not. Now you might say, but they both have x's. True, they both have x's. But this one has a power of 2, and this has a power of 1. That means they are not raised to the same power. Those would not be like terms or like parts. So in order for something to be simplified, because you're going to be asked to simplify things, you can have no grouping symbols. So how do you get rid of grouping symbols? The way you get rid of grouping symbols is with the distributive property. Here's a grouping symbol. If you want to get rid of it, distribute. It's gone. And all like terms are combined, which means any of these could add together and make 14x. This could make 10b squared. One of the common mistakes, if someone were to take 3b squared and add 7b squared, the biggest mistake I see is 10b to the 4th. That's the mistake right there. Don't write to the 4th. Keep the exact same exponent. If you had 3b squareds and someone gave you 7 more b squareds, you'd have a grand total of 10 b squareds. That's what you would have. Now if we want to see an example with the distributive property involved, getting rid of some grouping symbols, we could say, alright, let's say we have 7r plus 3r plus 2. In order for something to be simplified, it can have no grouping symbols. So to get rid of the grouping symbols, I will use the distributive property. There are no like parts. R and 2 can't add together. They are not like parts. They don't have the same exponents. They don't have the same variables. These two cannot be added together. But I can use distributive property to get rid of the brackets, and the parentheses. 7r plus 3r plus, biggest mistake, people forget to multiply over here as well. They just do the front one. You got to do them both. So 3 times 2 is 6. Now that you've done that, these two are like parts. They have the exact same variable raised to the same power. 7r's plus 3r's makes a grand total of 10r's plus 6. That's it. There are no grouping symbols and no like parts. Unfortunately, a lot of people write down this and then it's wrong. You can't add these together. They don't have, this does not have an R. Stay right here. That's as far as it'll go. Okay? And lastly, What if you had 7, and in parentheses, A plus B plus C minus D plus 2? You can still use the distributive property. The number on the outside will multiply by all the parts. 7A plus 7B plus 7C plus negative 7D, because I changed this stuff to plus negative, and plus 14. There are no like parts. That's as far as it would go. That would be simplified.